In this video, we're going to be looking at isomorphic strings, which is LeetCode problem 205. So this problem states, given two strings S and T, determine if they are isomorphic. Isomorphic strings are such that all the characters in S can be replaced to get T. So all occurrences of the character must be replaced with another character while preserving the order of characters. So they have to be in order. No two characters may map to the same character, but the character may map to itself. So if we look at example 1, we're going to replace the E with an A. Then we're going to replace this first G with a D. And we have a second G, which also needs to be replaced with D, and it does. So in this case, it's true. In example 2, F goes to B, the first O goes to A, and the second O also needs to go to A, but it doesn't. It goes to R. So this is false. In example 3 with paper, P maps to T, A maps to I, and we have another P, but it also maps to another T, so that's fine. And then E maps to L, and R maps to E, so that is true. So the way we're going to do this is using a hash map. So we're going to grab like the first letter here, E, and then we're going to tie it to the A. And then we'll loop through and make sure that any time we see an E, it'll be mapped to an A, and anytime we have a new character like G, it will map that to its corresponding character. So let's take care of the extraneous cases first. So if S is null, or S length, whoops, yeah, that's right, S length is less than or equal to 1, then we're just going to return true. All right, now let's create that hash map that I was talking about. And this is going to be of type character and character. And I'll call it map, and that will be instantiated as a new hash map. All right, now we just need to loop through all the characters in the first string. So I will start at 0. I is going to be less than S length, and I plus plus. All right. So what are we doing here? So we need to grab each character in both the strings. So define a char A equal to S, and then char at position I. So because I is initialized to 0, it will grab that first character. And the same thing with B. We'll make that equal to T, which is the second string, char at also I. All right, so now that we have these two characters, we can start to compare them. All right, so if map contains key A, so we need to check the hash map to see if it actually contains the value already. So if it does, then we need to do some stuff. But in the first pass through, it does not. So let's take care of this else condition first. Okay. So we don't have, does not contain A, so we need to put A. So we're going to map dot put A and B. So that will tie those two together. And that should be the end of that loop. Let's see here. That's there. Okay. And at the end, if it passes all our cases or all our tests, then we're just going to return true. Okay. So let's use the example foo and bar. So the first pass through, we're going to map the F to the B. The second pass through, we're going to map the O to the A. But the third pass, we actually have an O already. So it already contains the O. So we need to make sure map get A equals B. Now in our case, if it doesn't equal, then we're just going to return false. So in our example here, the second O is already contained inside the map, but it doesn't map to the A, which is what the second O maps to. And so this is going to return false. Now, the same is true. Let's say we reverse these. So we have bar and foo. So the first B maps, or the B maps to the F, and the A will map to the O. Now the R, it doesn't contain an R yet. So we can't just put R with O because we already have A mapped to O. So we need to check in the else condition, we need to check also that if map contains value, contains value B. So if it contains value B, if it doesn't contain value B, then we're going to put else, we're going to return false. So that will take care of that, the second, or the R mapping to the second O, as it's already in the hash map. And that is pretty much it. So let's debug this and see what we get. Now for my example here, I used egg and add. Actually, I'm going to switch this to use foo and bar, just because that's what we've been working with. All right, so let's debug this and see what happens. Okay, so the first pass through, we have characters of, let's see, A is F and B is B. Is that right? Foo bar. Yeah, okay. A is F and B is B in this case. So if the map contains the key, which it doesn't, if map does not contain the value B, so now we're just going to put A and B. So now if we look at our hash map, size 1, we'll have characters F and B. So we're going to go through this again. Now we've got the O and the A. Map does not contain that, so we're going to put A, B. So now if you look at the map, it'll be size 2, F and B, and O and A. Now we come down to here to the last two characters, O and R. Now the map contains key. It does contain the O, but if the map is not equal, which it isn't, because the O is equal to R, O is already equal to A, so the return is false. And this is our answer. So now let's run this through LeetCode and see if I coded it right. Hey, what do you know? Oh, this is egg and add, so that is true. With the example they used, and we'll submit that. And I like to do it a couple times just to see if we can't get better. There we go, 70%, 0.95 faster and less memory than roughly half of all the other submissions. So finally, let's go through the space and time complexity. So the contains value of the map is an O of n, and because we have it inside a loop, each time we run that is going to be n times n. So the time complexity is O of n squared, which is this line here. Now the space complexity is just O of n, which is this line here. So the only way we're going to need more space is if we increase the input parameters, which will increase the value stored in the hash map. And that is it. So thanks again for watching. Let me know if you have questions, and we'll see you next time.